Hello and welcome to this Getting Started with Microbit and PySupply Lower Node with the Things Network workshop. I'm Ryan Walmsley at part of PySupply and I'll be running this workshop. As a quick overview, in this workshop we're going to be going over how to use the PySupply Lower Node plus the Microbit to communicate with a LoRaWAN network. In this case we're using the Things Network, but other networks will work as well. We're going to set up MakeCode and set up the library as well inside of it. We're going to do a Hello World program where we're transmitting one basic bit of data and then expand that program to include a few sensors which are on a microbit. For this workshop you'll require a computer capable of running the MakeCode IDE. This with most computers, and ideally we recommend Chrome. You also need a microbit, a micro USB cable, a PySupply Lower Node, and be within range of a Things Network gateway. So first, set up MakeCode. First thing we're going to do is head to Google, then search MakeCode Microbit. There's a few different versions of MakeCode out there, but in this case we need to use the Microbit version. Once we're on the website, we're going to go New Project, and then get our hardware ready. To do this, we're going to first plug the microbit into our lower node, and then the USB into the microbit. The computer should then detect the microbit, and you should see it come up as a virtual USB drive. Then we're going to go to the cog in the top right corner, click Pair Device, and then Pair Device again. You should see the microbit appear up here. We can click Connect, and that means when we now go to download a program, it will automatically be able to load it to the microbit. Next we're going to go to the top right, then extensions at the cog. We're going to then search in extensions for LoRa, and click the IT Lower Node library. And that's it, we've already got the IDE set up. We're going to next drag in the set LoRa region block for EU868. You can select whatever region you like. We've got 4 regions programmed in. In this case, as I'm in Europe, we're using the 868 band. We're going to then drag in the initialize LoRa radio block. You can see that this requires an address, network session key and app session key, and we're going to get this from the Things Network. For this, head over to the Things Network console and log in with your account. Go to Applications, Add Application. In this case we're calling our application ttn-virtual-microbit-workshop. We're going to click Add Application, then Devices. We're going to register a device. We're going to call this one Microbit-1. We're going to generate the device EUI and then click Register. The next step we need to do is change it to ABP. So in the top right we're going to go Settings, click ABP, and we're also going to disable frame counter checks as we're doing a developing application. We're going to then view our keys and copy them one by one into the MakeCode IDE. Now these are all in there, we can get on with our Hello World program. So we're going to first drag our Forever block down underneath the OnStart block to make it a little bit neater. And then we're going to go to the IoT Lower Node library. So first we're going to drag our forever block down underneath the on start block to make it a bit neater, and then just to show you for now, we're going to download the program. We can see it's automatically downloaded already, and the display will go through a few steps. The tick shows that the frequency is set correctly. Then we get our low ready message. And that will be it for now, as we've got no body to the program. So what we're going to do next is we're going to first off add a little symbol to the screen. This will show us step by step what part the program's in. We're going to then drag in add a digital value. So our library uses the KNLPP to format it, and we're going to set that to true. And we're going to go down to the bottom and drag in our transmit lower data. We're going to then drag in another icon, so we know that it's then transmitted that data. And then we're going to add in a small delay of 5 seconds. So we're going to type in 5,000 into there. I'm going to click download again. And we should see any moment now that on our Things Network application page, that when the Microbit, so it goes through the initialization again of the frequency, says lower ready. And then, as we can see our payload. Now, as I said, we are using the KNLPP format, so we're going to actually edit our application to automatically decode the data. So we go back to application, payload formats, KNLPP, and now if we go to data, we should see that the next bit downloaded from the Microbit has automatically decoded as a digital in on port 1 and a value of 1 because we have it set as true. You can have up to 20 different values transmitted from the Microbit node at any one time. So next we're going to expand our project to use all the sensors we can on the Microbit. So I'm going to just move the on start block to the side to make a bit more room. And then we're going to add in an analog value block. We're going to put this above our transmit lower data. Now this I'm going to just set as 42 and change it to on channel 2. I'm going to add a temperature value block and set this to channel 3. And for the temperature value, we're going to go to input and drag in the temperature block. This uses the temperature sensor inside the Microbit's microcontroller to be able to transmit the actual value. We're going to next add in the accelerometer value block. The Microbit has got a built-in accelerometer, so we're going to add this to channel 4. Then go back to input. And we're going to drag in the acceleration blocks. And I'm going to change these from all X to X, Y and Z. Then next I'm going to finally add in the light value block. Now the Microbit's LED display can also be used as a light sensor. So we're going to add in the light level block and set that to channel 5. Now one issue is, because we're using the LEDs to display stuff, this will interfere with the light value, so before we're going to transmit it, we're going to add in the clear screen block, and then save this to our Microbit. So now, if I go back to the console, we should see the Microbit is running the program. Once again, it ensures the frequency set correctly. It says lower ready. And then we should start seeing our blocks come through. So as we can see here, we've got an accelerometer reading, the analog reading of 42, our original digital in of 1, and a brightness of quite bright. And we can see here they're coming through in real time. So now if I put my hand over it, we should start to see the temperature go up as well as the darkness go down. The temperature from where my hand's warming the Microbit up, and the darkness from where I'm blocking any light in. Sometimes the light sensor can misread from where the LEDs are, then reflecting back on Indev Celsius, but for this demo it works fairly well. So you can see as I move my hand away, it started to go brighter. Next I'm actually going to pick the node up, give it a bit of a shake, and we can see the accelerometer values start reading a significantly different value. Now, why Microbit? Our Microbit sensor has actually been one of our best-selling nodes, and this is because we believe people are using them a lot with their kids to get them into LoRa, as well as that they're fairly popular in schools, and also even in some businesses with being able to rapidly prototype very quickly using a block-based language. And we can see with some example projects, just a few we thought of up of ourselves. You can easily use it as a mapping node for using TTM mapper. This because you can power the Microbit off a couple of AA batteries, or you can use the USB battery pack. It's a nice small compact node, and you can run the app on your phone for the GPS data. You can also pair it with more complicated sensors, so while we use the built-in temperature and light sensor, you can actually use any other sensor which has a library under MakeCode and use your I2C pins which are broken out on the board. For example, one project is pairing it with a BME 280 to get a more accurate temperature, pressure and humidity sensor. So you can also use it as a response system, which a fairly popular application is where you have at the end of a store, customer satisfaction survey. You can have one button transmit yes I'm happy, one button transmit no I'm not, and the display on a Microbit provides that bit of visual feedback that some people need in their projects as well. And that is it for our workshop today. So as you can see, we're able to quickly get going on Microbit node, get it all set up, transmitting in under 15 minutes. We're able to expand our program to use all of the sensors on the Microbit, and we've gone through some more example projects. If you're interested in buying this board, you can go to our website, which is uk.pi-supply.com. If you want any more information, tweet us at PiSupply on Twitter, or send us an email on sales@pisupply.com. Thank you for watching, and hope you're staying safe and well at home.